Good afternoon, it's Tony Peters here with an update. It's February 1st, about noon, and I wanted to give an update since it's been a while since my last update. So I wanted to kind of give you guys an update on what I've been up to the last several weeks over the Christmas holiday, things of that nature, because it's been a little while. So one thing that you can notice right off the bat is that I've tried to consolidate considerably. There's still a lot of wires going around, but a little difficult to see right here, but I've got my star 1 and star 2, both layers for the solar test array, mounted to this arm. It's just a prototype arm that I made out of just some aluminum that I had laying around. It is a little long right now, or a little tall, because the servo or the stepper motor is working as hard as it possibly can, generating as much torque as it possibly can. So I may have to shorten the arm a little bit, but I'll demonstrate a little bit of what's going on. First things first, all the wires connecting, like I said, between both stars. So I have my one board here that I put together for the first layer, for the second layer, excuse me, and that's the one with the gathering IR readings, things of that nature, and it's going to be put right here. And also part of what I used for, described in the white paper, for measuring optical losses, because it'll actually measure what's coming back up at it based off the orientation. And this is what I put together for the first layer, which controls the calibration laser, and it also controls all the sequencing for the lights. So I'll show that here in a second. Let me adjust this here a little bit. Ideally, I put this box together so that this will eventually be this bad boy. So when I power it all up, you'll see that this one does not turn on yet. This one is my entire BAPSIS system. It's going to be maneuvering the arm. So I had to put its own independent cooling system in here. It has its own power supply reset, and then you could turn it on and off as you need to. Opening this up, getting a lot considerably smaller than it was before, but this is definitely the weak point here. That is my A3687 servo driver. It gets really hot, and it's putting out probably about 0.87 amps to provide power to the motor in order to hold up that weight right now. And like I said, that's about as much as it can. That's about as much as it can do right now. So I'll close this up, and I plan on doing something similar for all of these. As an example, I need to also wire some external reset buttons. As you can see from all these, all the red ones will just be reset, just in case you have to troubleshoot the hardware. But something like this will be for this apparatus here. Still haven't really perfected buying these. Remember, I used to get these from Radio Shack way back in the day. So pretty easy to cut into, and definitely helps with the modularity aspect of the project. So let me fire all this stuff back up. You'll kind of see that the servo, or I keep calling it a servo, excuse me, that the NEMA 17 has to it's stepping a little bit extra because it's working a little bit harder. It's really going into overdrive there. So let me just plug this all in, and what you'll see is everything boot up just the same way it does before, kind of go through its own little process. Might be kind of difficult to see just because of the lighting situation that I have in here right now. Okay, so as you can see, that this is trying to zero eyes right now, but it's not going to until I turn on the external power, or have it plugged in and then turn it on. So it's plugged in right now, but as a failsafe, I wanted to make sure I was able to control that with just a switch here. So right now it's measuring, well, the star 2 is measuring the range to the surface. It's also measuring the surface temperature of the solar cell, indicated by PV here. It's also indicating the surface temperature of what the actual artificial sun module subsystem is actually doing. So you can see there's a considerable delta there. This is actually measuring the UV intensity in milliwatts per centimeter squared, and this is the visibility or the visual lux, excuse me. So right now it's about 24 lux that it's capturing ambient. So if I turn this off, it'll go down to about 6. So UV, I'm getting about negative 0.06, 0.02. That's within the noise, really, for the sensor for the ML8511 per the spec sheet. So, and obviously I'm indoors right now, so I shouldn't be getting any UV. So I have this kind of here to have this rest on when I come back. So let's just turn that on. You hear the fans all whirring up because, like I said, this thing gets hot. The NEMA 17 itself is fine, it doesn't get hot, but it brings it down at a pretty steady rate. So I may have to see if I can do some creative programming there to help out. I also have to adjust this right here, my tact switch, to make it sure that it's zeroed completely. I have a laser calibrator. It's not in the video right now. It's across the room right now, but I'm going to use that to help get a perfectly level situation. So right now the angle is, it says it thinks it's 0 degrees, but that's based off of what I set as a calibrated setting. So what I can do is put in, let's put it right to the 90-degree position. And then you see, as you can tell, it needs a little bit of help. It's just literally a finger just to help get it up to that point. So right now, like I said, it is able to do all the calculations for you, kind of like with the basic CNC machines that I talked about before. I put in the steps, it spits out an angle or a distance for whatever you're trying to do. So right now, the LED driver is operational. And what I did was, I also, just as a means to compare, I pulled out an LED driver from another box module from just a product that was out there. And obviously this is something that's meant to take an input of 120 volts, of course 60 hertz, 10 watts, down to an output about 24 volts DC, and about 1/3 of an amp. So this does considerably more than this, but I kind of used it as a gauge of how should I really design an LED driver. So this, now the system is armed, I'm doing the bunny ears right now, so you're prepared to go through the whole cycle. So red, green, blue, white, UV, IR, and this will turn on your calibration laser. I don't know if you can see it, and turn it on and off. Just a little bounce toggle switch action there. And what it'll do is it'll go through the red, green, maybe if I turn this off, you might be able to see it, blue, white, UV, IR, and then it goes back through. What I'd ideally like to do is have another LCD that you can see what actually is highlighted, maybe right over here in this corner, saying, okay, red is on, blue is on, but you can actually just take a look. I have another short clip I'll be putting up to kind of just show you through the sequence of that. But right now, let's say we just want to move it to a different beta angle. So it's at 135, and I can set it to whatever color I want. I could do green, let's maybe move that over there, you know, go through the motions there, and then maybe I'll put it back to some other angle in this quadrant. You know, and then switch it to white, get a gauge on what the main center of mass is, turn it back off, switch to UV, and then move it right back over top of the cell or something like that. Kind of get an idea of what the reflections might be at around beta angle 0, so directly staring right at the cell. So this is a quick little update. Just wanted to show you guys exactly what I have been working on, because I've been kind of quiet over here, just really trying to consolidate, but I'm very happy with the work so far. Next step is I'm going to be taking my test cells that I have, which I cannot find in my many drawers in my workshop. Oh, there we go. So my basic 1 watt cell. So what I'll do is I have it plugged in, or I have it with a jack ready to be plugged in to start getting some measurements. I also have my trusty multimeters of all different shapes and sizes that I can start just plugging right in start getting some measurements, see what exactly is going on. Obviously I need to troubleshoot the motor a little bit more and the driver assembly inside here. So I'm going to monkey around with that a little bit more. Maybe actually adjust this arm a little bit so that it gets a little bit less torque demand. But that's where I'm at right now. And any questions, please feel free to let me know. Send me an email directly. Thank you.